Hai, Assalamualaikum warahmatullahi wabarakatuh. Today, our group I want to present about my PBL. Our project is titled Automatic Plant Watering System. My name is Muhammad Zahir bin ABIDIN and my friend NASRULLAH ZIKRI bin ZULKIFLEE, Muhammad AMIR SYAHIR bin JAMAL ABANA and Muhammad FIKRIE bin RIDWAN. And we from 2BI and section 1/1 and our lecturer is Sir Muhammad Farid bin Ibrahim. Okay, for the project title, we will create the system for automatic plant watering system. And for the project description, in our project, we simulate an automatic plant watering system with notification to the farmer. The system includes the Arduino board, soil moisture sensor, which used to measure the soil moisture content, ultrasonic sensor, which is used to measure the level of water inside the tank, module used to send text message to the farmer whenever the pump change its status. LCD used to display the level of water and moisture content together with the pump status. And two pumps, one for watering the plants and the second one for supplying water to the tank. And for the member one, Nasrullah.
Okay, for the input is soil moisture sensor. So output is when the value obtained from the soil moisture sensor falls, the water pump start. The process is to measure volume of water contained in soil. For member 2, Amir.
Okay, for input, water pump motor. Output, water pump starts to run and supply the water to plants. So the process to supply the water to plants. And member 3, Zahir.
And for input, me is LCD. Me use the output is to display the percentage level of water, percentage moisture content together, and pump status at LCD. And the process to display the level of water and moisture content together with the pump status and two pumps, which is one for watering the plants and the second for supplying water to the tank. And Fikri?
Okay, for my input is ultrasonic sensor. For my output, display the level of water. And for my process is to measure the level of water inside the tank and module and use to send text message to the farmer whenever the pump change its status. Okay, next. We go to the introduction. Okay, for introduction, watering is the most crucial cultural activity as well as the most labor-intensive task in the daily operation of a greenhouse. An automatic watering system helps save the efforts needed to deliver water plants when they are needed. The key elements of the watering process are when and how much to water automatic plant. Watering is designed to make gardener jobs easier. Okay, then we carry on to our system operation. Alright.
Okay, for system operation in this system, soil moisture sensor senses the moisture level of the soil. If soil will get dry, then sensor low moisture level and automatically switches on the water pump to supply water to the plant. As plant gets sufficient water and soil get wet, then sensor senses enough moisture in soil, after which the water pump will automatically get stopped. And for the system requirement, this is the hardware and software component that required in the design and implement as follow. For the first hardware is we use Arduino Uno. The Arduino Uno is a microcontroller board based on the ATmega 328. It has 20 digital input output pins, of which 6 can be used as PWM outputs and 6 can be used as analog inputs. 16 MHz resonator, a USB connection, a power jack, and in circuit system programming ICSP, header, and a reset button. For the liquid crystal display LCD that we use, LCD 20x4, which is the function is to display the value of moisture content percent and the volume of water level percent inside the tank, level of water and moisture content together with the pump status and two pumps, one for watering the plants and the second one for supplying water to the tank. And for visual terminal device, visual terminal device is a tool in Proteus which is used to view data coming from serial port DB9, and also used to send the data to serial point. And for the type of sensor, soil moisture sensor, Nasrullah.
Okay, for the soil moisture sensor, it used to measure the volume of water contained in soil. This lead allows the current to pass through the soil and in return calculates the resistance value to measure the moisture level. If there is more water in soil, then soil will conduct more electricity, means less resistance value along with the height value of moisture. In the same manner, if there is less water in soil, then soil will conduct less electricity, means high resistance value along with low level of moisture. So for the ultrasonic sensor, used to measure volume of water inside the tank. The watering pump is supplied the water from the tank to the farm, and the tank pump is supplied the water from the source to the tank. For the flow charts, we go to AMIR, SYAHIR.
Okay, then we go to the flow chart. Start with the power supply and Arduino Uno, and then go to the relay, and then watering pump and tank pump. Go to motor at watering pump and tank pump, then go to plant, and then go to the soil moisture sensor that is measure to volume of water content in soil. Then the sensor for water pump and tank pump go to ultrasonic sensor. Then both of ultrasonic sensor function is measure the volume of water inside the tank. Then we'll display at the LCD. Then go to the GSM module, and next the farmer. We'll send the message to the farmer. Okay, next.
Alright, for the circuit diagram, we open the Proteus app. For the circuit diagram, we use soil moisture sensor, Arduino Uno, LCD, ultrasonic sensor, pump, and veto terminal. Alright, for the coding, for the first two line code is I've just include the library files for a liquid cluster display, but also I have used a software serial library file. The software serial library allows me to create different TX and RX pins for the GSM module that I have. So I've used, so instead of using pin number 0 and 1 as my transmitter in the receiver pin, I've just create another pins which is pin number 2 and pin number 3 as receive a pin and also transmitter pin. I always prefer this way of of connecting my devices, so I don't always use the pin number 0 and pin number 1. So I always using this software serial to create another TX in the RX pin. Okay. Pin number line number 4. The number to number 8 is just the definition of echo pen is connected to pin. And number 9, pin number 9 and trigger pin number 10. These are the pins for the ultrasonic sensor. Time pump is connected to pin number 4 water and pump to pin number 13, and the moisture sensor to pin number A0 right. So I have also the variables along duration to get duration of ultrasonic sensor once I turn on the trigger bin, right? And also the distance to store the readings from the ultrasonic. I have a variable moisture value, maybe used to store the moisture reading, and also I have a distance percent and a moisture pattern. These are the variable that will store the percentage value of this distance reading and also the percentage deliver moisture content reading, right? You see I've create via an object sim 900. This is be my object that will allow me to send the text message to the GSM, right? And also another object LCD in the setup function. I just enhance the two objects LCD and also the same 900, right? Okay. Although I've just configured the another pins and the output, as you see here, you can just alright. You can see this project summation file. This that you my code and then we go to LCD set cursor and set start from 00 colon 101 and it will display this. Okay, for the example, I run this. For the first, it display embedded project, automatic plant, operating system, ZAHIR, FIKRIE, ZAINAL, welcome. Alright. And then for the level sensor, FIKRIE.
Okay. Okay, for the level sensor, I start by getting the distance measuring of water level inside the tank. So if we know to get the readings, to make the distance using ultrasonic sensor, we only need to hide the trigger pin for some microseconds. And then just turn it off and then you deposit functions while echo pin is hide to get the distance, to get the duration, and multiply the duration with this cost. And if we normally using it as a width from the web formula to get this constant, saturation times 0.017 will be getting the distance, the actual distance or level of the water inside the tank. So I use my function to convert the readings to percentage form bright. Okay, and then at the end of the loop, I just call the function here condition functions. I create several functions, different message for different message to be sent. I have the void estimate that will be that has a watering pump. So the message I have sent get to the another message. All right. And another message from the right condition function, I just create a condition if statement. So if the distance percent, the percentage of water in the tank is above 95, 65, I will be turning off the tank pump. And also if the moisture percentage volume is less than 85, I will be turning on the watering pump. This is the main condition. If the tank level is above 65, okay, enough amount water inside the tank, so we need to turn off the tank so that to stop supplying the water from the well to the tank. And if the moisture content is below 85, automatically we are going to water the plants. All right. So to turn the watering pump off inside the tank is below 65%. Okay, it will be turning hide the tank pump, so that's to supply the water to the tank. To those are the two main conditions that I use, and also I have another function for the LCD using those status. Okay, then I will give to next person.
Okay. For the void LCD, LCD will display at the row 1 is tank level. Second row is moist content and apa tu? Third row is W pump status, and for the third row is the T pump status. It have four situation. For the LCD1, to watering pump status is on and T pump is on, also on. For the LCD2, for the watering pump status is off and T pump is status is on. For the void LCD3, For the watering pump status is on and T pump status is off. For the LCD4, go to watering pump status off and T pump status off. Okay. We go to the simulation.
For the simulation, if distance percent more than 65% and moist percent less than 85%, the LCD will display tank pump is off and watering pump is on. The farmer will get the message for the tank pump and watering pump. Okay, next, if distance percent less than 65% and moist percent is more than 85%, the LCD will display tank pump is on and while the watering pump status is off. Then the farmer will get the message that the tank pump is on and watering pump is off. Next, if the distance percent more than 65% and the moist percent is more than 85%, the LCD will display watering pump is off and the tank pump also off. The farmer will get the message that the SMS that the tank pump is off and watering pump is off. Okay, next, if the distance percent less than 55% and moist percent is less than more 85%, the LCD will display tank pump is on and watering pump is on also. Okay, that we see the DC motor. The DC motor of watering pump and tank pump is moving. Okay, then the farmer will get the message that tank pump is on and watering pump is on.
Alright.
Okay, for the conclusion of our report, although it seems to be the more demanding and challenging, there are many other possibilities like creating complex connections of plants of similar variety or so-called Internet of Plants. Also, using more than one sensor is another idea for an experimental venture. But there are also many experimental and challenge-like ideas such as using solar power supply, timer for setting irrigation system and others. However, independently of the way used to construct it, there is no doubt that this system can be very helpful in solving many problems. From those that seem harmless to those that are on the scale of the most important and most dangerous one for human population. By means of the system, it is possible to control the amount of water released from the process of watering the plant. This system automation is designed to be assistive for the university pump. Also, it can very helpful for humanity in general. Agriculturists, artisans and botanians could have the biggest benefit of using our system. Okay, that's all from us. Thank you very much.
Thank you.
Alright, thank you.